Hi students, welcome on the lesson on multiplying and dividing rational expressions. Okay, so let's first look at what multiplication of fraction looks like, and we'll try to translate that into multiplying with rational expressions. So if you're multiplying these two fractions together, probably what you do is you try to simplify them first. So what I'm going to do is I'm going to prime factorize all these terms. So for example, 10 is 2 times 5. So this is like saying 2 times 5. And on the denominator, 12 is like saying 2 times 2 times 3. Okay, so all I'm doing is prime factoring all these fractions. Okay, so and then the 8 would be 2 times 2 times 2. And then the 20 would be 2 times 2 times 5. Okay, well what we have here is we have common factors on the numerator and denominator. So look that the 5 can be cancelled out, and notice that there are 4 2's both top and bottom. So notice that all we have left in the numerator is factor of 1, and all we have left in the denominator is a factor of 3. So using prime factorization, instead of multiplying 10 times 80 and 12 times 20 and then simplifying, I can prime factor, so find all the factors that are common in the numerator and denominator, and cancel them out. Alright, so in this case, I've added some letters into this expression. So notice that we have 6xy squared. Okay, and if I was to write that in prime factorization, so same kind of idea, write all the factors out, I would have 2 times 3 times x times y. And on the denominator, well, it would be 5y, which would be simply 5 times y. Okay, now if you guys remember fractions, whenever you divide by a fraction, what we like to do is we like to reciprocate the sign. So what we have is a multiplication here, and at the same time, you're going to reciprocate the fraction, and you're going to have, instead of writing 8, I'm going to write 2 times 2 times 2, which is all the factors, and we have times x times y times y. Okay, so this is 8x squared y squared, so 8x squared y squared. And this whole thing is divided by 15, which is 3 times 5, times the factor of x. So basically what I've done is I've written these out as complete factors. And don't forget, I flipped this fraction around because I changed the sign from division to multiplication. Okay, well, let's get rid of the common factors. So notice there's a 3 here. Okay, so now we have 1y here, and we have 1x. And that's, I think, all we can do. So if you were to combine the solution, you'd have 2 times 2 times 2, which is 16. You'd have 2 x's and 3 y's. So you'd have x squared y cubed. And on the denominator, we'd have 5 times 5, which is 25. So again, this is the simplified version of this expression. Okay, so now let's attach that to multiplying rational expressions. So what I would recommend you do first is you completely factor everything. So factor, just like we did here, I completely wrote it in terms of factors. I'm going to do the same thing over here. So notice that I can factor a common factor of 2 there. So what I'm left with is 2 over x minus 3 times 2 times x minus 3. And this is all divided by 10. If you want to write 10 in terms of 2 times 5, you can. That is your choice. Okay, well, before I keep going anywhere, I'm going to find the non-permissible values. And the non-permissible values here would be whenever the denominator is equal to 0. The denominator is equal to 0 when x equals to 3, so x cannot equal to 3. And now I can get rid of any common factor. Well, notice that the factor of x minus 3 is on the numerator and denominator. I can also change this 2/10, or this 2/10, pick the one you want, to change it to 1/5. And the final fraction we have is 2 times 1 is 2, 5 only on the denominator. So what this is telling us is this expression right here, no matter what value of x you plug in, other than 3, would give you 2/5. Okay, so you could plug in x equals 1, x equals 5, x equals negative 1,000. All those values would simplify to 2/5. The only one you can't plug in is x equal to 3. Okay, so we're going to do the same thing, maybe a little bit more factoring in this case. So notice that you have a trinomial here that you have to factor out. So what we have is x minus 3, x plus 1, divided by a common factor of x here. So you have x times x plus 1. And then over here you have 10 times x, so we can't really simplify that. So times 10x. Again, you could change the 10 to 2 times 5. Okay, that's your choice. And then on the denominator you have a difference of squares, which is x minus 3, x plus 3. Okay, so non-permissible values before I simplify anything. Okay, so anything on the denominator that gives us 0. Well, there would be x plus or minus 3 from those factors. So x cannot equal to plus or minus 3. And then you have an x cannot equal to negative 1. X cannot equal to negative 1. And the last factor we sometimes forget, if the factor of x exists, then that means x cannot equal to 0. Right? Because if you plug in 0 there, you'd have 0 times 1, which is 0. Again, the non-permissible values are just values of x that would make the denominator equal to 0. Okay, and at this point we can cross out any common factors. So the x plus 1 is a common factor, numerator, denominator. Okay, we also have the factor of x, that's factorable both top and bottom. And we have the factor of x minus 3. So what we're left with at the end is 10 on the numerator and x plus 3 on the denominator. And this is the simplified version of this expression, as long as you don't use these non-permissible values. Okay, so a couple more examples. Very similar to the other ones. Notice that in this example we have a division here. Okay, so this is going to make you flip this fraction and turn this into a multiplication. Okay, so what we need to do is completely factor, find all the factors in the numerator and denominator. So over here you're going to have the factors x minus 2 and x minus 3. So two numbers that multiply to 6 and add to negative 5. And you divide by x plus 5 times x minus 3. Again, two numbers that multiply to negative 15 and add to 2. Okay, so we're going to change this into multiplication. And so now this is now on top. So there's a common factor of 2 here. So the common factor of 2 leaves me with 3x minus 4. And on the denominator we have 2 minus x, 2 plus x, which comes from the difference of squares, 4 minus x squared, and that's what you have. Okay, so before going anywhere, as normal, non-permissible values. Okay, well these are pretty easy. We just look at the denominator here. So we have x equals to negative 5 is a non-permissible value. We have x equals to positive 3. So again, any x values that make the denominator equal 0. We have x equals to 2, so 2 minus 2 is 0. We also have minus 2, so 2 minus 2 is 0. So x cannot equal to plus or minus 2. And I'll pause a little bit. There is a bonus mark here for there is one other non-permissible value. Okay, well, hope you thought about it just a tiny bit. There's another non-permissible value here. Where does it come from? Well, it actually comes from here. And without going into too much detail and describing it very difficultly, notice that it's our original question, this expression here starts on the denominator. So that is a non-permissible value. Another way to look at it is this whole fraction can never equal to 0 because you're dividing by this fraction. So if you had 0 divided by 5, this makes this 0, therefore you cannot divide by 0. So that's where that becomes 0. And you also cannot have 0 on the denominator. So this creates another non-permissible value. So we have 3x minus 4 cannot equal to 0. And if we solve for x in this expression, so bring the 4 over and then divide by 3, x cannot equal to 4 over 3. So this is another non-permissible value. So there are actually 5 factors here that give us non-permissible values. Okay, well, I guess that's the hard part. Right now it's just crossing out common factors, right? So you have x minus 3, that one's easy to find. It doesn't look like we have anything else, but if you look carefully, x minus 2 here and 2 minus x have the exact opposite signs of each other. So the factor of negative x plus 2, positive x minus 2, those are opposites. So therefore, to get rid of them, we're going to factor a negative 1 over here. And what that's going to do is going to change the sign of both of those, right? So now what you have is negative x plus 2, negative x plus 2. Those two factors can now cancel themselves out. But don't forget you have this negative 1 factor that came out to get rid of those. Okay, and that's all we can get rid of. So now on the numerator, we have 2 times this times -1, which would be -2 times 3x minus 4. And on the denominator, we have two factors. We have x plus 5 and 2 plus x. And I will leave them written in that form. A lot of people might actually change the 2 plus x to x plus 2 because it doesn't actually make a difference. But that would be your simplified version with these non-permissible values. Okay, so what you really need to get out of that is that whenever you divide by a fraction, both the numerator and denominator cannot equal to 0. So you're going to have extra non-permissible values. Alright, and the last example, notice that we have a multiplication and a division in this expression. So don't forget, this whole thing cannot equal to 0. Okay, that's something that we learned from the last example. And what we're going to do is we're going to factor everything out and get rid of all the common factors. Okay, so on the numerator here we have a common factor, right? A common factor of 2x, and we have x minus 8. Okay, on the denominator we have a trinomial. We have, look, two numbers that add to, multiply to 8, add to -9, which would be 8 minus 1, 8 minus 8, 8x minus 8, times, and here, times, we have a common factor of 5, so we have 5 times 1 minus x. On the denominator, we have 2 times x. Okay, so here comes our division, so we're going to switch the sign to multiplication and flip those two terms. Okay, so here we have x plus 1, x minus 1, which is a difference of squares. That now moves up top, right? And on the denominator, well, we have 10 times x, so just 10x squared. Okay, well, let's try to get rid of as many things as we can. Notice we have an x minus 1 that can get rid of. Notice that this one and this one could have also been cancelled out if you take out a factor of -1. But because we have these two, it might be just easier to do that. We have 2 and 2, we have x and x. Notice I canceled them separately because those are two different factors. 2 times x and 2 times x. Okay, and we have an x minus 8. That one's fairly obvious. And we have one more if you didn't catch it. Notice that we have 5 over 10. That can be simplified to 1 over 5. Alright, well, what do we have left here? On the numerator, we have 1 minus x and x plus 1. So we have 1 minus x and x plus 1. And on the denominator, you look closely, all you have is 5 and x squared left. So this would be 5x squared. Alright, I just noticed that I didn't give you the non-permissible values. Okay, so don't forget, I'm not going to take my non-permissible values from here. I'm going to take my non-permissible values from here. So we can still find them at the end of the question if you forget to find them. Just make sure you don't get them from here. You get them from your original equation, or expression, sorry. Okay, so non-permissible values. Okay, let's look at the easy ones. X cannot equal to 1 and 8. So x cannot equal to 1, x cannot equal to 8. Okay, we have another one, x cannot equal to 0 over here. Okay, x cannot equal to 0. We have x cannot equal to 0 as well here because you'd have 10 times 0 times 0. Okay, so you cannot have 0. We already got that one. And don't forget over here, we also have these from the denominator over here, right? So x cannot equal to 1. We've got that guy already. But we also need x cannot equal to -1. And these are your non-permissible values. Alright guys, that's it for the lesson. I hope you learned what you needed to learn. And don't forget, if you have any questions, please ask your teacher in class. Good luck.